This is part 1 of our lesson on measurement conversions. Please make sure you have your video notes so that you can follow along. Pause whenever needed. Okay, let's talk about the different types of measurements. So this is our STAR 6th grade mathematics reference chart, and it shows you the different measurement systems. We have the customary measurement system over here on the left side, and we have the metric system on the right side. Why do we have two different measurement systems? The customary system is the measurement system that we've been using in the United States for a very long time. Very, very long. And the metric system is the newer measurement system. And this is what's used mainly around the world. And it's actually a little bit, to me, it's a little bit easier than the customary because it's based on our number system. And our number system, we have the tens number system. So it's pretty easier to do conversions with the metric than with the customary. You'll see the metric around the world. You really won't see the customary anywhere else other than the United States. So lucky us, we get to learn how to do conversions in both systems. Okay, so let's go ahead and get started. Mrs. Torres is mailing a package that weighs 1 5/10 pounds. The post office charges by the ounce to mail a package. How much does the package weigh in ounces? The first thing you need to do is you need to identify the two different measurement systems you're talking about. So we're talking about the package in pounds, but the post office charges by the ounce. So we need to figure out how many ounces this 1 5/10 pound package weighs. So we're going to be converting pounds to ounces. So we're going to look at our STAR reference chart. And here we have pounds to ounces. 1 pound is equivalent to 16 ounces. We can use proportions to solve this, to do these measurement conversions. First thing you're going to do is you're going to write the ratio that you know, the rate that you know. We know that 1 pound, and this is from your STAR chart, and I always make my L kind of like this, like a cursive L, just because I don't want it to look like a 1, and that is equivalent to 16 ounces. And I'm going to use the OZ abbreviation for ounces. What is it that we're wanting to change? Well, this is what we're going to get from our problem. We're given that we have 1.5 pounds. So the pounds are going to be in the numerator. So I'm going to put my 1.5 pounds. And we're trying to find how many ounces. So this is our unknown. So I'm going to use the variable n. So all you have to do is solve it. With proportions, we use scale factor to solve. So you could go scale factor horizontally, but I find on these measurement conversions, it's a little bit easier to go vertically. So we're going from the known to the unknown. So we're going from the top to the bottom, from 1 pound to 16 ounces. How do you get from 1 to 16? You multiply by 16. Use the same scale factor over here. We're going to multiply the 1.5 by 16. So off to the side, we're going to do a little bit of math. Remember, when multiplying by decimals, take them out. Multiply as if they're whole numbers. So we're going to do 16 times 15. 5 times 6 is 30, carry a 3. 5 times 1 is 5 plus 3 is 80. I'm ready to move to my tens digit, so I have to put a placeholder here. Now I can multiply. 1 times 6 is 6. 1 times 1 is 1. And I'm ready to add. 0, 14, carry the 1, 240. But that's not my answer because remember, we have 1 decimal place. So we need 1 decimal place in our answer. So our answer is actually 24 ounces. So a package that weighs 1 5/10 pounds will weigh 24 ounces at the post office. Example number 2. An ice cream store sold 4.5 gallons of chocolate ice cream. How many quarts is this? So identify the two measurements we're talking about. We're talking about gallons and quarts. So if you look at your STAR reference chart, if I could pull it up here, there we go. We can see that 1 gallon is equal to 4 quarts. So this is going to be our starting ratio. 1 gallon is equivalent to 4 quarts. This is what we know. And what are we changing here? What are we trying to find? We're changing our gallons into 4.5 gallons. So the gallons go on the top. Instead of writing this in fraction form, I'm going to write it as a decimal number. It's a little bit easier to work with. We know that 1/2 is 5/10, or think of 50 cents, and the 4 whole. So this is 4 5/10, or 4.5 gallons. And we want to know how many quarts does this equal. So this is our unknown, our variable n. Okay, come back over here. We're going from the known to the unknown. So we're going from the top to the bottom. So find the scale factor. We're going from 1 to 4. That means we're multiplying by 4. Use the same scale factor, go in the same direction. We're going to multiply 4.5 times 4. Again, this is a decimal, so take it out. Let's multiply as if it were a whole number, 45. 45 times 4, we have 20, carry the 2, 16 plus 2 is 18. Now remember, the answer is not 180 because we have one decimal place. So let's put one decimal place and our answer becomes 18. So 4.5 gallons is equivalent to 18 quarts. It's not too bad, is it? Okay, one more example. The top row of bleachers in the gym is 8 3/10 meters long. How many centimeters is this? All right, what are we comparing? Meters and centimeters. So now we're going to be dealing with the metric system. So if we come over here, find the meters, and here we go. 1 meter is equal to 100 centimeters. So we're going to write this as our first rate. 1 meter is equal to 100 centimeters. And in our problem, we're given 8 3/10 meters. So that's going to go over here in the top, 8.3 meters, and we're trying to find how many centimeters. That's our unknown, our variable n. And we want to keep it proportional, so we put that equal sign. Okay, let's find the scale factor. Again, we're going from top to bottom, so we're going from 1 to 100. We would have to multiply by 100. So we're going to do the same thing over here. Multiply the 8.3 times 100. Now, you could take out that decimal point and do 100 times 83, or we can do the shortcut. When we're multiplying by powers of 10, all we're doing is we're increasing the place values by the number of zeros. So there are 2 zeros and 100, so we want to increase this digit by 2 place values. To do that, we take the decimal point and we move it to the right. Move it 1 place, we move it 2 places. So our new decimal is now at the end. When you have a whole, you have to fill that in with a 0. So this becomes 830. So our answer is going to be 830 centimeters. And now you're ready to do your 3 practice problems. Make sure that you're using proportions to solve these. Set up your proportions. Once you're done with all 3, take them to your teacher to have them checked.